Yeah, so good afternoon, everyone. My name is Amit Kumar Pal, and I'll be continuing the session that we had left on the last term. So, we were solving the exercise on the limits, and we had completed almost half of the exercise. So, we'll be covering the remaining exercise in this session. So, I think whatever we had covered in the last session, so you must be clear with the fundamentals of the limits and how to approach the given formula and how to check whether you can directly put the value into the question, or you have to do some changes so that you can convert the non-rational form into the rational one. Okay, what do I mean by non-rational form? Any form that is not valid form. Okay, so like in case of limit, the invalid forms are like invalid forms are like uh, a 0 by 0 form or infinity by infinity form, 0 into infinity, or 0 to the power 0, or infinity to the power 0, or 1 to the power infinity, etc. These form are basically invalid forms because these all forms make the value of the function some kind of irrelevant, or you may say that you can't determine the value of function directly. Okay, so that's why we apply the limits so that we can find the tentative value of the function that would be approaching as the value of variable will be tending to some given value. Okay, so that was the fundamental about the limits. So yeah, if we move to the questions that we had left on the last time, so just hold on, let me come to the page number. We had also discussed one important form, that is L'Hopital rule, that is frequently used while solving the questions. So this is some easy tricks that you can directly apply while solving a lot of questions during some of your tests, like be it a JEE Mains or JEE Advanced. So L'Hopital is a simply straightforward formula that you can apply to find the answer in most of the cases, and it almost give the same answer that you would be finding by some algebraic expression or some trigonometric formulas, but L'Hopital is some direct way to come to the answer. Okay, so yeah, so we had completed almost 23 questions. So if we come to the question number 24, so question number 24 basically says that you are again given the implicit definition of the function. So what do you mean by implicit definition of the function? It is basically for different ranges of x, the function is changing its value. Okay, so let's say we come to the question number 24. So again we are given two values, limit x tending to 1 fx, where fx is equal to x square minus 1 and minus of x square minus 1, and this is for x less than equal to 1, and this is x greater than 1. Okay, so these are two definitions of the function, and you have to find the limit. So by means of limit, what do we mean? Basically we means that limit x tending to 1 minus should be equal to limit x tending to 1 plus. So this is what we mean by the existence of the limit. Okay, so if we find this value, so this value will become coming from by putting the x equal to 1 in the definition. X is less than equal to 1, because when the x is tending to 1 minus. Okay, so let's say this is some graph and this is x equal to 1. Okay, so basically x is coming from this side. Okay, so this is x is 1 minus, and this side is basically x is 1 plus. Okay, so for this range we'll be taking value of the function this. Okay, and for this range we'll be taking this function. Okay, so this is what we mean by the implicit definition of the function. Okay, so if we find this value, so we'll put x equal to 1 directly. So this comes 1 minus 1 equal to 0, and this comes minus 1 square minus 1, so this is equal to 2. So you can say that 0 is not equal to 2, so you can say that limit does not exist. Okay, limit does not exist. Okay, so this is about this question, and this was straightforward question, and There is another method by which you can solve these type of question, and that is basically graphical method. Okay, so what we do in graphical method, we basically plot the graph of the function for different ranges of variable x. Okay, so let's say this is given our function 25, that is fx equals to mod of x by x for x not equal to 0 and 0 for x equal to 0. Okay, so you have to find the limit for x tending to 0. Okay, so you if you are familiar with definition of mod function, so what it does for x less than 0, fx is basically equal to minus of x by x for x less than 0. Okay, and for x equal to 0, it is already given 0. Okay, for x greater than 0, mod of x equal to x. So fx, what would be fx? Okay, so fx is simply x by x for x greater than 0. Okay, so these are three cases. So if we further define, so this is basically additional information that I have noted here, that is how we deal with modulus function. Okay, for less than x and for greater than 0. Okay, so fx is basically equal to -1, 0 and 1 for x less than 0, for x equal to 0, and for x greater than 0. Okay, so we can clearly see that the graph of the fx should be something like this. Okay, this should be approaching to -1, and this will be value at x equal to 0, and this should be graph of fx for x greater than 0. Okay, so you can see that as we are approaching to the x equal to 0, there is a jump in the function. Okay, the function is jumping from -1 to 0, and for just greater than 0, the function is jumping to +1. Okay, so you can see that we can't find the left hand limit equal to right hand limit equal to value of the function at that point. Okay, so we can say that left hand limit is not equal to right hand limit is not equal to f of 0. Okay, so this simply means that limit does not exist. Okay, so this is about this question, and for the question number 26, the same would be applicable also, because here in this case we have mod function in denominator rather than numerator. Okay, so uh, 26 will also be the same case. We don't have answer. Okay, so limit simply doesn't exist. And for question number 27, so for question number 27, it is better to see the graphical representation of fx. Okay, so let's say, so this is our question. Okay, so if we plot the graph of fx equal to x minus mod of x minus 5. Okay, so how does this comes? So the graph is basically something like this. Okay, this is x equal to 0, and this is x equal to this should be x equal to 5, and this should be x equal to -5. Okay, so you can see that as we are approaching to the x equal to 5 from left hand side or right hand side, so we'll be going closer and closer to the 0. Okay, so from both the side we'll be getting the same result. Okay, so that means this limit is simply equal to 0. Okay, and in this case limit actually exists because the function is continuous. Okay, there is no break in the function. Okay, and since the function is there is no break, so uh, as we'll be getting closer to the x equal to 5, will almost be landing to the x y equal to 0. Okay, because as the x is approaching to the 5, the graph is basically intersecting the x-axis. Okay, so for this question the answer would be 0. All right, so if we finally move to the question number 28, so it says that you are given implicit definition of the function for different ranges of x, and it is given that limit extending to, so you have to find a and b. Okay, so you just have to understand the basic concept here, because for the limit to exist, left hand limit should be equal to right hand limit should be equal to value of the function at that point. Okay, so by that means we can calculate a left hand limit by simply putting x equal to 1 in the first definition. Okay, so this should be equal to a plus b and equal to what would be the right hand limit. Okay, so right hand limit will be by putting x equal to 1 in this b minus ax. Okay, so this would be equal to b minus a. Okay, and the value of the function at x equal to a is equal to 4. Okay, so this is already given. So finally you have two equations and two unknowns, so you can solve this. So from here 2b equal to 0, so this gives b equal to 0, and if you put b equal to 0 in any of the expressions, so we get a equal to minus 4. Okay, but if you put b equal to 0 in this equation, then we get a plus b equal to 4, then this gives a equal to 4. Okay, so what do you mean by this? We are basically getting two values of a. Okay, actually there is a small mistake here. So this basically gives it 2a equal to 0, then this gives a equal to 0. All right, and if you put a equal to 0 in this expression, then this gives b equal to 4. Okay, so these are the values of variable a equal to 0 and b equal to 4. That would be finally our answer. Okay, so for this value, the function satisfies the given condition, that is left hand limit equal to right hand limit equal to value of the function at that point. Okay, so in question number 29, it is given that you are given some polynomial expression, that is fx equal to x minus a1 into x minus a2 dash dash x minus an. Okay, so you have to compute the limit for a is not equal to a1 a2 a3 an. Okay, so you can see that if we directly put the value into the function expression, we don't get any form that is of form infinity by infinity or 0 by 0 form like that. So we can simply say that we can directly put the value into the function expression. Okay, so if you put x equal to a1, then the term x minus a1 equal to 0. Okay, and if 0 is multiplied to the remaining expression, then final result will also be equal to 0. Okay, whereas if you put x equal to a, then the value of the function is this is basically limit x is tending to a, fx is equal to a minus a1 into a minus a2 into, so this is our answer, because we don't get any form that is illegal to us. The final answer that we are getting is basically finite answer. Okay, so this is about this question, and if we move to the function question number 30th, then it is given that you are given some definition of the function, and you have to tell for what values of a the limit exists. Okay, so let's say there is some value of a for which this limit exists. So if we put the value of a in the given expression, then we get fx limit extending to a is equal to mod of a plus 1 and 0 and mod of a minus 1. Okay, so these are basically limit for left hand limit, and this is right hand limit, and this is at x equal to a. Okay, oh sorry, this is at x equal to 0. Okay, so if we simply draw the graph of this function, then we can also simplify clearly observe the result more clearly. Okay, so if you draw the graph of mod of x plus 1 for x less than 0. Okay, so this should be some y equal to 1, and this should be some graph of mod of x plus 1. Okay, and for x equal to 0, this is graph, and for y for right hand side this should be graph, okay, because this is mod of x minus 1 and this is mod of x plus 1, okay. These graph are basically some conversion form of mod of x. So by shifting the mod of x below and above, we can find the graph of mod of x plus 1 or mod of x minus 1, okay. So you have to find the values of x for which the given limit exists, okay. So you can see that whatever be the value in this region or in this region or in this region, this region, so at all these regions the limit basically exists. We don't have any uh, restrictions because we are not getting any form that is not valid, because for all these value the value of the function would be finite, okay. So we can say that for any value of a belong to R except 0, because if a is equal to 0, then right hand limit would be this, okay, right hand limit would be minus 1, okay, and left hand limit would be plus 1, okay. So you can see that for left hand limit and right hand limit won't be equal, okay. So the a should not be equal to 0, otherwise it can be any real number, okay. So if we move to the next question, so this says that if the function fx satisfies limit x tending to 1 fx minus 2 upon x square minus 1 equal to pi, then evaluate limit x tending to 1 fx, okay. So if you observe this question number 2031, okay. So this is actually a good question so far, because you have to analyze the given question carefully, okay. So firstly, you need to notice that we are given the limit of this, okay. So we are given limit of this function. So this is any function gx, okay. So we are given a limit of gx, okay. You can say that gx limit x tending to 1, okay. This is equal to pi. So we are given this value, okay. So you know that for the given expression minus 2 by x square minus 1, this is equal to pi, okay. So as you can observe, as the x tend to 1, okay, so this value is tending to 0, so means we can say that this should be, for this to act as a some finite limit, this should be some form of 0 by 0, alright, because if this value doesn't tend to x 0, okay. So if fx minus 2 doesn't tend to, if this value is not tending to 0, then we'll be getting some form of like finite by 0, okay. So this would simply tend to infinity, okay. So this limit won't exist, okay. So for this limit to exist, this fx minus 2 should also tend to 0, okay. So that means limit x tending to 1, fx minus 2 is equal to 0, okay. So we can say that limit x tend to 1, fx should be equal to 2, okay, because only then the limit of fx minus 2 would be tending to 0, okay. So this was the question was straightforward, but you have to analyze that why we are doing this way, because the given limit is finite, and to make the finite limit, the limit should be of the form of 0 by 0, okay. So that is the key concept behind this problem. And if we move to the last question of our exercise, so you have basically given some expression, and you have to find the values of m and n for which both the limit x less than 0 and x 0 to 1 and x greater than 1 exist, okay. So what we are going to do in this question is basically firstly checking what are our critical point, okay. So what do we mean by critical point? The critical point are basically the point at which we are not sure whether the limit will exist or not, okay. So let me make it clear what we mean by a limit exist or not, or at critical point, okay. So if you see the above expression, this is some quadratic function, so its graph would be something like parabolic, okay. And this is some linear function, so its graph would be something like linear, and this is again quadratic form, so this graph would again be some parabolic, okay. So you know that these graphs are basically continuous, okay? So we don't need to check the continuity of this function for inside range, okay? What do you mean by inside range? Okay, we means that for x less than 0, the graph would be something like quadratic, okay? So it will be continuous at all those points. So we don't need to check at any point less than 0, okay? But our main focus is on the point 0 and 1, because at this point we are not sure whether our function will be uh, continuous or not, or the limit exists or not, because at this point the function actually is taking jumps, okay? It is jumping from this function to this function, and at x equal to 1 this is jumping from this to this, okay? So we just have to check at x equal to 0 and 1, okay? So at 0, if we find the left hand limit, so it would be m into 0 square plus n, so this is simply n, and right hand limit at x equal to 0, it would be n into 0 plus m, okay? So this would be simply equal to m, okay? And similarly, if we check at x equal to 1, then LHL would be equal to n into 1 square plus m, so this should be equal to n plus m. And if we check a right hand limit, sorry, the left hand limit would be by putting the value in above function, okay? So n into 1 plus m, okay? So this would be n plus m, okay? And right hand limit would be by putting the value in the expression nx square plus m, okay? So this is n1 square plus m, so this is n plus m, okay? So you can see that these value basically left hand limit and right hand limit are n plus m, okay? So that means at x equal to 1, this condition always holds. Left hand limit will always be equal to right hand limit, okay? But for at x equal to 0, for LHL equal to RHL, this n should be equal to m, okay? So we can simply say that for this condition, the above both the limit will always be exist, okay? So our final answer would be for all integral values, okay? So for all integral values, the limit always exists, okay? So this is all about exercise, and after that we'll further move on some other concept, that is basically the concept of derivatives, okay? So if we finally move to our new concept, that is derivative. So as हमने पहले भी देखा था डेरिवेटिव का कॉन्सेप्ट, लाइक in the starting of this chapter, while providing the small description of this chapter, so we had seen that derivative is some basically extension of the limit concept, and we had also related this concept with the slope of the tangent at that point, okay? So we found that f dash x is nothing but limit delta x tending to 0 f of x plus delta x minus of fx by delta x, okay? So we had derived this formula as well by using the concept of slope, okay? So normally this is expression, but depending on the condition of left hand limit and right hand limit, this split into two parts that are limit extending to delta extending to 0 plus and limit delta extending to 0 minus, okay? So these are two parts of the derivative, but we'll be using the same concept while solving any questions, okay? So this is also called the first principle of the derivative, okay? So whatever standard formulas that you will come across in the physics or in the mathematics that are basically differentiation or so on, these all are basically derived from the first principle, okay? So if we like, if I write some of the basic functions, so like x to the power x to the power n, the dy dx is n of x to the power n minus 1, and for trigonometric function like sin x, this is cos x, and this for cos x, this is equal to sin x minus sin x. Okay, and for log x, this is 1 by x, and for e to the power x, this is simply equal to e to the power x. Okay, so like if I derive any one of the case, just to make sure familiar with the concept of first principle. So let us take log of x. Okay, fx equal to log of x, and we'll find the derivative of this function by using the first principle. Okay, so if we write the expression like the first principle, so f dash x, that is dy dx of fx is limit delta x tending to 0 log of x plus delta x minus log x by delta x. Okay, so this is our expression, and if I write it further, then this is equal to limit delta x tending to 0 log of if I take x common, then this comes equal to x of 1 plus delta x by x minus log x by delta x. Okay, so if we apply the formula of log property, that is log of AB is equal to log of A plus log of B. Okay, this is formula. Then if we apply this formula in above expression, then this become equal to delta x tending to 0 log of x plus log of 1 plus delta x by x minus log x, and न्यूमरेटर में हमारा आ जाएगा डेल्टा एक्स. ओके, so these two terms basically cancel out, and we are only left with limit delta x tend to 0 log of 1 plus delta x by x upon delta x. Okay, so how do we solve this limit? Okay, so if you are familiar with the expansion of some function, so you know that the expansion of function like log of 1 plus x is x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4, and this continues up to the infinity terms. But here the condition is that the x should be tending to 0. Okay, so this is this is expression for the expansion of log of 1 plus x. So if you see the question above, we have delta x by x. Okay, now delta x is tending to 0 and x is some finite value. Okay, x हमारा कोई finite value है, but delta x almost 0 पे जा रहा है. So delta x by x is extremely small. Okay, so this is almost tending to 0, so we can apply the expansion in this case. Okay, so this finally becomes limit delta x tending to 0 delta x by x minus delta x by x whole square by 2 plus and so on. Okay, and this is delta x. Okay, so we can cancel delta x from delta x, so we finally left with delta x tending to 0 1 by x minus delta x by x. Okay, so now you can see that we have delta x tending to 0. Important thing to note here is that our variable is delta x, not x. Okay, x is constant for us, but only delta x is tending to 0. Okay, so this is important to note here, and even if we put delta x directly into the answer, so we'll be only left with 1 by x minus 0. Okay, so this is our finite answer, and this will be equal to 1 by x. Okay, so this is the derivation of f dash x equal to 1 by x for log x. Okay, so this is how the first principle is utilized to find the derivative of the standard formulas. Okay, so we can apply this principle basically to the any questions to find the derivative. Okay, our exercise is basically dy dx of x square minus 2 at x equal to 10. Okay, so since there is no mention that you have to find whether from the first principle or from any other principle. So we'll directly apply the formulas of a derivative here. So you know that derivative of constant is equal to 0 and derivative of x to the power n is n times of x to the power n minus 1. So this is equal to 2 into x to the power 2 minus 1 minus 0. Okay, so this is 2x. Okay, and now you can put the value of x equal to 10 directly into the question. Okay, so this is 20. The important thing to note here is that you have to put the value of x at the very last part. Okay, you cannot put something like you cannot directly put x here and finding the derivative, because that will always be producing the zero output. Okay, so that is important thing I reminded you, because some people get confused when it's just beginning of derivative. Okay, similarly, like in a second and third part also, you have to just find simply the derivative. Okay, like for the 99x, the derivative would be equal to 99. Okay, so the derivative is constant for all the value of x. Okay, so the answer would be 99 for all the cases. Okay, so if I finally come to the question number 4, so you have to find the derivatives here by first principle. Okay, so like if we take the question number one of the question, like let's start with question number one itself. So this is x cube minus 27. Okay, so by first principle we will have limit x delta x tending to 0 f of delta x plus x minus fx by x delta x. Okay, so if we simply put the values here, then we'll get x plus delta x whole cube minus 27 minus x cube plus 27 by delta x. Okay, so yeah, this will get cancelled, and we can use the formula of a cube plus b cube here as well. So this will give limit delta x tend to 0 x cube plus delta x cube plus 3x delta x whole square plus 3 delta x x square minus x cube by delta x. Okay, so this get cancelled, and since delta x is common in all the terms, so this get cancelled at 3 minus 1 and 2 minus 1. Okay, so this this will finally produce a limit delta x tend to 0 delta x square plus 3x delta x plus 3 times of x square. Okay, so as you know, there is no denominator terms, because the main concern for us was the denominator term, because that was causing some weird output, that is infinity form. Okay, but here there is no denominator delta x. Okay, so we can directly put delta x equal to 0 in this expression. So this will finally give us 0 plus 0 plus 3x square. So this is 3x square. Okay, so this is about this question, and if we see the fourth part, because that is a more general form of all of the above parts. So fourth part is x plus 1 by x minus 1. Okay, so again we'll be doing the same thing, that is f of x plus delta x minus fx by delta x. Okay, so this is limit delta x tend to 0 x plus delta x plus 1 by x plus delta x minus 1 minus x plus 1 by x minus 1 by delta x. Okay, so this is our questions, and if we take LCM of the denominators, LCM of the numerator part. Okay, so limit delta x tend to 0, and this will be x plus delta x minus 1 into x minus 1, and in the numerator we'll have x plus delta x plus 1 into x minus 1 minus into x plus delta x plus 1 and in the denominator whole will have delta x. Okay, so we have to solve this much of expression right now, and we'll be doing it quickly because a lot of terms would be getting equal to 0. Okay, so let's say we multiply firstly x plus 1 into x minus 1 plus delta x into x minus 1. Okay, and for the second term we'll get x plus 1 into x minus 1. This is basically equal to minus 1. Okay, x plus 1 into x minus 1 plus minus x plus 1 into delta x. Okay, and in the denominator we'll have actually in this part we can directly put delta x equal to 0 because this much part is not producing any infinity form. Okay, so we can directly put here delta x equal to 0, so this will give us x minus whole square into delta x. Okay, so if we solve this expression, then this gives us limit delta x tending to 0, and this terms and this term get cancelled. Okay, so we are left with only delta x times of x minus 1 minus delta x times of x plus 1 into upon x minus 1 whole square into delta x. Okay, so this delta x cancel from numerator and denominator, so we'll be finally left with x minus 1 minus x minus 1 by x minus 1 whole square. Okay, so this finally gives us minus 2 by x minus 1 whole square. Okay, so that is all about first principle. You don't have to do much, but there is some calculations, and you have to carefully see where you can apply the direct substitution, whereas in what cases you need to simplify it further so that you don't get any infinity by infinity form like that. Okay, so this was about the first principle, and if we finally move to our next question, that is question number 5. So fifth question is basically x to the power 100 by 100 plus x to the power 99 by 99 x plus 1, and you have to finally prove that f dash of 1 is equal to 100 times f dash of 0. Okay, so we can directly find f dash x here. So f dash x is equal to dy dx of fx. Okay, you have to simply apply the formula dy dx of x to the power n is equal to n times of x to the power n minus 1. Okay, so this finally gives us x to the power 99 plus x to the power 98 plus x to the power 97 plus 1. Okay, so this is f dash x. So if we put x equal to 0, so f dash of 0 is equal to 0 plus 0 plus this is finally 1, so this is equal to 1. Okay, and f dash of 1 equal to 1 plus 1 plus up to 1, so this is 100 times. Okay, so this is 100. Okay, so you can clearly see that f dash of 1 equal to 100 times of f dash of 0. Okay, so and in the next question you have to find again the derivative of n a polynomial. So there is nothing much to do in this question as well. In question number 6 you just have to simply apply the concept of derivative of x to the power n minus 1. Okay, and it is given that a is constant. Okay, so our variable is basically only x. Okay, so you just have to treat the a as a constant. Okay, what does chain rule means? Basically that let's say you have some function of the form f of g of hx. Okay, let's say this is some function and you have to find derivative of this function with respect to x. Okay, so how do you calculate this derivative? So there is nothing much to do, but you have to simply move with sequentially. Okay, so this is nothing but equal to f dash of g of hx, and after that derivative of g dash with respect to hx and finally this is h dash of x. Okay, so this is all about chain rule. So you just have to identify the function definition, basically what is contained in inside of what function. Okay, and after that you have to just simply apply the formula. Okay, so if we see the question number, like second question, that will describe it better. Let's say x square plus b whole square. Okay, so if we see this function, so this is somewhat like y square. Okay, some function of y where y is equal to ax square plus b. Okay, so how do you find that this derivative? So this is nothing but derivative d of y square and finally derivative of d of y by dx. Okay, so if we apply this formula, then this will get a dy dx of, so we get 2 times of ax square plus b to the power 2 minus 1 into derivative of ax square plus b. Okay, so this is basically the extension of chain rule. So this finally gives us equal to 2 times of ax square plus b into 2ax. Okay, and b is constant, so its derivative is 0. Okay, so this is our final expression, basically for ax square plus b. Okay, so this is all about this question. And if we come to question number third, so that is x minus a by x minus b. Okay, so if you know the derivative of fx by gx. Okay, so this is nothing but gx into f dash of x minus fx into g dash of x by gx whole square. Okay, so this is a formula in case of the function are in form of division. Okay, so we can say that the derivative of this function is equal to x minus b into derivative of x minus a, so into 1 minus x minus a into derivative of x minus b, so this is equal to 1 upon x minus b whole square. Okay, so this finally gives us equal to a minus b upon x minus b whole square. Okay, so yeah, this is all about this question. And for question number 8 also, you have to just do the same division formula. So we can quickly see that. So this is nothing but equal to x minus a into derivative of this numerator. So numerator derivative is nx to the power n minus 1 and minus x to the power n minus a to the power n into derivative of denominator upon minus a whole square. Okay, so this finally produces equal to nx to the power n minus 1 into x minus a minus x to the power n a to the power n plus. So this is the final answer, but you can also further simplify it if you wish. But like you can, or you can do this way as well. Like you may expand x to the power n minus a to the power n in terms of x minus a into some function gx. So yeah, so that was another part, another way you can solve this question. So but that is easiest method you can solve this question. So if we next move to question number 9. So in question number 9 also you have to just simply find the derivatives, but you just have to apply simple rules of multiplication and division and so on, like the derivative of fx into gx. Dy dx of fx into gx is nothing but equal to gx into f dash x plus fx into g dash x, where dash dash sign basically indicate where g dash x is equal to dy dx of gx. Okay, so you have to apply this formula in the remaining part. Like let's say we see the question number third. So for third we have x to the power minus 3 5 of plus 3x. Okay, so this is our first function and this is our second function. Okay, so we'll apply the same multiplication rule. So this will be equal to x to the power minus 3 into derivative of this function. Okay, so this is 3 plus 5 plus 3x into derivative of this function. So this is nothing but x to the power n form, so its derivative would be equal to n times x to the power n minus 1. Okay, so this should be minus 3 into x to the power minus 3 minus 1, that is minus 4. Okay, so we get final answer is 3x to the power minus 3 plus minus 3x to the power minus 4 5 plus 3x. Okay, so this is our final answer. Okay, likewise, if we move to our question number 6, so this is equal to 2 upon x plus 1 minus x square by 3x minus 1. Okay, so you have to solve this question. So this is basically combination of two functions, that is fx, this is fx, this is minus of gx. Okay, so we can do it by simply uh, differentiating both the function one by one and then combining the final result. Okay, so this is nothing but 2 of x plus 1 to the power minus 1 minus x square by 3x minus 1. Okay, now to differentiate this function we can simply use the formulas for differentiation. So that is 2 of x to the x plus 1 to the power minus 1 derivative of this function. What would be the derivative of this function? So this would be minus 1 x plus 1 to the power minus 2. Okay, minus the derivative of this function. Okay, so for this function this would be minus 2 of x plus 1 to the power minus 2, and if we differentiate this term, so this is basically by multiplication rule. So 3x minus 1 of x square minus x square into 3 upon 3x minus 1 whole square. Okay, this is first function into second function into differentiation of the first function minus first function into differentiation of second function. Okay, actually there is small mistake here. So this would be equal to x derivative of x square, so that would be equal to 2x. Okay, so we finally get equal to 6x square minus 2x minus 3x square by 3x minus 1 whole square. Okay, so if we combine our final result, so this would be equal to minus 2x plus 1 to the power minus 2 minus of 3x square minus 2x upon 3x minus 1 whole square. Okay, so that would be our final result for this question. And the next question is about another part about the first principle. So you have to find dy dx of cos x from first principle. Okay, so if you apply the simple formula of first principle, that is delta x tending to 0, this is cos of x plus delta x minus of cos x by delta x. Okay, so if you expand this with a trigonometric formula, then this will be equal to cos a plus b. This is equal to cos of x into cos of delta x minus sin x into sin of delta x. Okay, minus cos x by delta x. Okay, so if you see this formula, then this is limited delta x tending to 0 cos of x. If you take cos x common from these two terms, then this will be equal to cos x minus cos x of 1 minus cos of delta x minus of sin x into sin of delta x by delta x. Okay, a bit of calculation is involved, but if you are solving with first principle, then this much is expected. So you basically need how you can manipulate the given expression to some solvable form. Okay, And if you know by the example, like as we had derived in this limit part, the limit of this function as x tend to 0 is equal to 0. Okay. If you scroll a bit above, or you see in the initial part of this chapter, I had derived this result that this limit is equal to 0. Okay, so if we split the above part, above limit expression, then this will become equal to limit delta x tending to 0 minus of cos x 1 minus cos x by delta x minus of sin x into sin of delta x by delta x. Okay, so you know that this whole expression is going to be equal to 0. Okay, and you just have to deal with this expression. Okay, so this is equal to limit delta x tending to 0 0 minus sin x into sin of delta x by delta x. Okay, again you know that this value is tending to 1 because the limit of x tending to 0 sin x by x is equal to 1. Okay, you know this result. Okay, so you can apply that result. So this finally gives limit x tending delta x tending to 0 minus sin x. Okay, so this will finally give to us minus of sin x. Okay, so this is our final answer for the derivative of cos x with first principle. Okay, so if we try to solve our question number 11, so the question number 11 basically involves solving the questions based on trigonometric formulas. Okay, so whatever we have derived by this point, we just have to apply the principle of trigonometric plus derivative. Okay, so this is all about you have to apply here. So like let's say we take first question, that is sin x into cos x. Okay, into cos x. Okay, so one thing you can do is apply, this is some function of fx into gx. Okay, so you can say sin x into derivative of cos x, so this should be minus sin x, and into plus cos of x into derivative of sin x, so this should be cos x. Okay, so this is cos square x minus sin square x. Okay, so this is nothing but equal to cos of 2x. Okay, and if we solve like question number 5, so like 3 of cot x plus 5 times of cosec x. So if you remember from the list of derivative formulas of trigonometrics, so you know that derivative of cot x is minus cosec square x, and derivative of cosec x is minus the cosec x into cot x. Okay, so dy dx is basically equal to minus 3 cosec square x minus 5 times of cosec x cot x. Okay, so this is a direct answer that you can write here, and you can further simplify it by taking cosec x equal to common, and but this ain't gonna help much because this is already in a simplified form. Okay, likewise, let's say if we move to our last part, that is seventh part, so this is choice of tan x minus 7 times of sec x. Okay, so again you have to apply simple formula, so this would be equal to derivative of tan x is sec square x, so this is twice of sec square x minus 7 times of derivative of sec x is sec x plus sec x into tan x. Okay, so this would be our final result. Okay, so that's all about this chapter of limits and derivative, and I think we have solved almost all the questions that are relevant to this chapter by covering the important and necessary concepts and applying them in the problems. Okay, so the last will we will be trying to cover this in our next lectures, and by far I think you are okay with the concept of application of